Good morning, everyone.
Good morning.
Yeah, I'm happy to be here once again. Today we are going to be doing the most important aspect of the data analytics and data science job or task. So everybody, you will have to unmute yourself, except you have a noisy background, because we have to interact together today, as we'll be going through a lot of things we do to clean data. So as a data scientist or analyst, most of the time, your work is majorly cleaning. And when you say cleaning, we talked about the percentage of the job. We say mostly some people can spend 80% of their job doing data cleaning. If you don't clean your data very well, that is going to be give you a biased outcome. So you have to spend a lot of time during data cleaning. And typically 70% of your time, from 60%, 70%, 80% of your time will be on data cleaning. So this is the most important aspect of the task. What we will be doing, we will quickly go through some basic steps that are necessary for data cleaning. But before then, let's quickly recall all what we've done, or majorly what we did in our last class. Let me share our last class. Yeah. This was what we have in our last class. We have data. We try to import some of these libraries that we use. And we say some of the libraries we use, they are something like NumPy, that you are going to install the NumPy. When you install that, you also install Pandas, then you install Matplotlib. So we also install Seaborn. There are other libraries, but for now, these are the major ones we are going to be working with, and we have treated that in our last week. So let's quickly recap. After installation, and additionally, if you want to be using a data that is stored in Excel format, you have to also install open PySL libraries as part of the package you're gonna use. And after the installation, the next thing we do is to import all these libraries we have installed. And we demonstrate, it was demonstrated in our last class, how to import these libraries. Example is importing Pandas. We also imported NumPy as an NP, and we imported Pandas as PD. But before then, we also talked about different ways of getting our data. We say we can create data by ourselves. Some ways of creating data is using list. We have list of student name, math score, chemistry score, and biology score. This list can be used to prepare a data frame. We say one of the ways to use this list to prepare this data frame is to put it in a dictionary. If we put it in a dictionary, we can convert the dictionary to a data frame. And this was what we did. The dictionary, which was named Student Dictionary, was passed into this data frame by saying pd.dataframe, the name of the dictionary. This was the name we gave to the dictionary. If you can still remember, we say student dictionary. So which were passed into the data frame. Please, can you hear me well? Can you hear me clear?
Yeah.
Okay. So the dictionary now has been converted to a data frame, the format we want. This is actually what we want. Let's add something to our dictionary. If we call, okay, let's add another data to our dictionary, to our data frame. If we have this as our data frame, there is another thing we can do. One other thing we can do is that after having this data frame, we can still add another extra column to this data frame. We have student name, we have the mascot. Let me run it again because this would have been the dead shell by now. So this has been run. This has been run. Let me imported. Then this is the dictionary we declared, and we turn it to a data frame. Then we want to print out our data frame. Then the data frame has been printed. This is the data frame. And another thing we can do, we can have an empty data frame. If you have an empty data frame, for example, we can start loading it with data. The data could come from let's say, list. Let's have another list. We have math score, chemistry score, biology score. Let me have maybe let's create another list of a score. Let's say geography score. Let's just say geo score or geo mark. Let's just call it geo mark first. If you have another score that is geography score, and for this number of entry, of course, we have 10 entries there. We have 10 names. We must curate data that would be equal to the number of entry we have. For example, let's go for the first data that is David. If the score for the David, let's say David score like 60. So if I put 60 here for David, and let's say Aisha is not having any score, let me just say NP dot NaN, that is no value. There's no value for it, or I can just as well just put empty space. Let's say another person's called 35, and another person called 73. Then I have 34. I have let's say I have another non-value MP dot non-value. That is what it means. There is no value for it. NaN. Is it up to 10? 1, 2, 3, 4, 5, 6. Let me have another. Maybe these people did not come. Dot NaN, non-value. This one, they did not come for the let's have another MP dot NaN. So they didn't come. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's another person's call maybe 93. And finally, the last person's call maybe 49. This is a score for a particular student, okay, for geography, and we want to add it to this our data frame. Of course, it means we should have another column here that we have something like geography score, and then we'll have the list with it. What we can do is to curate, let me add another space column, okay, is to call for our data frame. This is our data frame, which we call student data frame. If we call this data frame normally, and if I say the data frame, and I want to check if I have something like a mass score, I can just do it like I want to index. Okay, if I want to index the student's name out of this data frame, what I could do is I can just call for this. And like I want to index it, okay? Give me something like data frame from this student. Is there any column that is student name? If we have something like that. Give me what the students' names are. So if I run it, it's going to give me all the student names. This is it. David, Aisha, Bola, this. That is, I'm accessing each one of them, each column, one after the other. If I want to access this, I could easily just come and do like this. Copy this. I can type it as well, but I don't want to make mistake. And put it here. Instead, I put it and say, okay, access this for me. If I run it, it should give me the math score. You can see that. Now, if I want to call for geography score now, for example, there will be nothing like geography score in our data frame. You can see it's an error. There is nothing like that in this data frame. So the data frame is not having anything like geography score. So now it means like I could easily put geography score now and say, okay, since you don't have geography score in the data frame, let's put geography score. This geography score should now be equals to the geography mark. If I put geography marks here and I run it, it's going to look for the data frame and see that there's no geography score and now put the geography score as the heading of the column and then put the geography mark as the other data under the geography score. If I now run this again, this geography score will now be appended into the geography, into the student data frame. So if I run the data frame now, student data frame, I just want to copy every time, but this time around it's not working for me. So if I run this student data frame, the geography score will have created another column. The data frame will have created another column called geography score and append the scores under or the data in the geography marks to it. So if I run it, I'm going to have it, you can see geography score. Now, I added another score to it. This is geography score. Anytime you see any hen, it means the such individual has no score for that. So, which is just any hen. So there is no score for it. And that is now the geography score. Now, if I want to add another score to it, maybe I want to get the average, I can add it. I can say, okay, is there any average score? Maybe average for everything. If there is no average, I can put the average. But for me to get the average, let me just call it okay, maybe I should just say average score. What is the average score going to be? The average score is going to be the addition of everything I have here, from math score to chemistry score to biology score to geography score. So I should be able to add them, but now it's now in data frame. But assuming it were to be in a list format, I could have called on a way to add them, but I should also still be able to use if or stuff like that to add another column that we check all the scores under each one of these and add them together. So, and if I've done that, then I could just add that geography score, average score to it. What can I do? How can I do that? I could just say, okay, check for every column under this my student data frame. If the column is under the math, chemistry, and biology and geography, add them together and divide by, okay, just add them together and divide by, okay, 1, 2, 3, 4, since I'm considering 4 different courses. Add them together and then give me the output and record it as the average score under that particular index, for example, David. So I could do that. But for now, I may not want to do that because it's going to be me iterating through the column, which we don't know yet. But these are possible things. what I'm saying, we can always add them together and create more column to our data frame. That is how to get different columns and create. So now we say we can create data frame through by ourselves. Another way we can get data is to go to public repository. If you go to a public repository, you can download the data, and sometimes you can even have to scrape the data online using different libraries. Like in Python, we use what is called Beautiful Soup to scrape data from the web. At the same time, we could also get data through questionnaire. You serve questionnaire like the one served by BDPN to assess, maybe ask questions about your feelings at work or things like that. So you could get data through questionnaire. And those are various ways of getting data. You can also get data from database. A database has been created. Creating database is not your work. That will have been created. After it has been created, your job is just to go to the database and fetch the information you need. That is another aspect. Talking about SQL and stuff like that. So that is another aspect. All you just need to know about SQL is just being able to read data from the database. But if you are able to create the database, good, is still an advantage. But majorly, your work is just to fetch the data you need and start your analytics job. Now, we have talked about how to get different data. Once you create data, it's easier. You can create and continue to add, so create, continue to add to your data frame. For example, I want to add again, I add another column, and I can add another column, as many as possible. But if the data is already available, which you are not the one that is to curate it, it could be available in the major one we normally do with could be available in CSV file, it could be in Excel file. If it is in CSV file or Excel file, there is a way we read them, which we did in our last class. You can see we're able to read. For example, let me just delete all these. I don't need this any longer. We're able to read, for example, yeah, here we say we got data that is insurance data, and it's in form of Excel. So all we did was that we use pd.read Excel because this is an Excel format. And after we're able to read, and then we get the data from the where we stored the data. And another one was that we were able to read another data of diabetics data, which is in the form of CSV, and we use the same thing. pd.read CSV. The other one was pd.read Excel. We also have pd.read JSON if the data is in form of JSON. So those are the way we could read all this data. Reading the data is no more our problem. Of course, we can read data and we can look at the data, visualize the data, just inspect the data. Those are not a major problem, just to read the data into your notebook. But another important thing that we want to go into is that after reading the data, how do we clear the data or clean the data rather? The data we get, in most cases, they are going to be a dirty, very dirty data. So we have to ensure we clean. For example, even the one we created, we introduced some problem in it. You can see this one is NaN. Okay, what should we do to this non-value? Should we call for the student to come and rewrite so that we can input, or should we just input 0 for them? We cannot work using NaN. This is going to be a problem for us. So we always come across data with different issues. If the student were to input this data by themselves, sometimes they could intentionally input something like a string. For example, let's add another data to this. Let's add another subject. Let's say the English score, English mark, English language mark. To this, I want to I want to intentionally introduce another problem to the data. And you will see the beauty of cleaning your data before working, before making any insight from it. If this is what the score in English language, and let's say this person want to put something like 50, and maybe somehow inputted 50i. This becomes a string. Maybe it was a mistake. Okay, instead of 50, let me just put O. Yeah, someone put something like this. Let's say after that, I have another one that wanted to say 14 and now say, okay, maybe 41 and now say 40i. Of course, this is going to be a string. It won't take it. So let me just say 4i. Or maybe I should put exclamation. This person, let's assume this one did not come. This one that is 45, okay, maybe we should just change this one to 60 now. And then instead of this one 73, let's just take this one off. I want to alter the data. Let this one be someone that wanted to say is 100 maybe, and this fellow is called 70. Instead of saying 70, mistakenly says 700 20. And maybe this one that wanted to say, let me clean this up, 99 or maybe 93. Okay, maybe this fellow want to say 67, and now inputted 6 here again, 667 instead of 67. So let me see, 1 2 3 4 5 6 7 8 9. Okay, we still have one more. I'll let this person call maybe 50. There's a problem with my, okay, I think it's good now. I think this is also a problem. When you copy, you should always be mindful of what you copy sometimes. So because, okay, I think this is good. Oh, comma. What is the problem? A comma. Okay, yeah. There should be a comma here. 1 2 3 4 5 6 7 8 9 10. Okay, we were dealing with 10 entries. Okay, now since I have this, let me now append it to, again, let me append it to this data frame, the student data frame. This is the student data frame. I want to append another score that is called, let's call it this time around, what is it? We are saying geo score. Let's call it ink score. We are going to do as if we want to index, and we call it English scores. I don't know if you use scores. You can call it anything. And since it's not in the data frame, let's say is equals to what we have as this, and put. It will automatically have a column that is called English scores, and then put the data of this English score on it. So if I run it, oh, what is the problem? Okay, I did not put this thing in, yeah, I think it should work now. You will always come across problems like this, so that is a normal thing. Then let me call on the English, the Discord. Let me just call this and run it. Now we should have another, you can see, we have another column, English score. So now I will come back to this. We understand that we can curate we can get our data. You read the data. After you read the data is definitely going to be sometimes, mostly, is going to be a dirty data, like the one we created now. Is already a dirty data. What should we do when you have a dirty data like this? Now,
Sorry, Abdul,
yeah,
sorry. Can I ask a quick question, please? It's a fairly minor point, but it's just something I'm slightly curious about, particularly
okay,
as we're talking about sort of data quality and data integrity. So, for English scores where you've got, well, 50,
yeah.
to me, it looks like five and the letter O
Yeah,
rather than zero. So why, when you ran it, why didn't that, from a data quality point of view, why wasn't that picked up as an error?
no, it's not going to be an error because when I was running it, I already created it as a string.
Oh, of
You can
course.
see. So you
Yeah,
can see I said
yeah,
for I already created it as a string.
yeah.
If I remove the string and I run it, it's going to be an error.
Mm.
So I intentionally put it as a string. This is to tell us that these are likely things we can come across when we have our data. This one is not a very big data. That is why you can see the 5 and O instead of 50. If it's a very big data, you may not even notice that. So what we want to do now is, what can we do to notice things like this? So if it's a very big data, like for example, I have a very big data here, the one we imported in our last class, that is about, you can see this data is about 1,005, okay, 158,701 row. So if we have this kind of data, merely just looking at it like this, you will not be able to notice that. I hope you get that now.
Yeah,
Yeah,
yeah.
you won't be able to notice it. Even all these little stuff where we have high in our data now, where we have high, okay, not high exclamation, you will not be able to notice that because it's going
Mm.
to be a very voluminous data. So you will not be able to notice that. All we want to do is, what can we do to notice what happens in every column? For this column, what happens there? In this column, what happens there? Is there any problem with this column? Is there any problem with this? Is there any problem with this? And is there any problem with this? What are the problems in every column? And what can we do to solve all the problems in the columns? I hope you
Yeah,
understand.
yeah, yeah, yeah.
So that is the task. And that is the most difficult task that we are going to face when you are as a data science or data analytics analyst, rather. You always face this problem. So now you just reason like, okay, let's just go back and remove the O. Let's just go back and remove the high. It goes beyond that because it's only what you notice that you can remove. If you don't notice it, there's no way you can remove that. And if you don't clean it very well, by the time you get to building a model, if you want to go to a machine learning model, you want to build a model, your model, some of the model, they are not friendly with things like this. They will not allow it to run. And at the same time, your model is going to give you wrong prediction
Mm.
because you fed it with a wrong, it was fed with a wrong data. The quality of the data is very, very important. And that is why we have to talk about data wrangling. When
Mm.
dealing with data wrangling, what are the steps that we are to we normally, when you see a data like this, you don't bother yourself, you don't worry yourself with this. All you just have to worry about is that, what are the steps I have to take to ensure that I see this data to be as clean as possible. So some of the steps that we are going to be looking into, they are: number one, let me check the steps I have for you here. Um, coming. Because I want to check a file that I already have, so that I won't be repeating. I will be able to go through a good step for us that we can follow. Let me just quickly check one of my file. Chris, are you with me?
Yes, we're here.
Okay. After you have gotten your data, one of the first things we can do is to check for the shape of the data. So how do we check for the shape of the data? Are you still seeing my notebook? Can you see this notebook?
Yes.
Okay. One of the first things we do is to check for the shape of the data. So this is a very small data set because we created it by ourselves. So how do we check for the shape of the data? Normally, we could have just looked at this data and say maybe 1, 2, 3, 4, 5, 6. This is we have 6 rows, 10 rows, 6 columns. So if you want to check for that, we can use and sometimes when you run it, it will automatically tells you the rows and the column. For example, what you have there, what you have here, the other data I showed, like this one, you can see we already know the number of rows and number of columns here. We have 158, 701 rows and then 18 columns. And the same way, we can know this one by simply checking the shape, using what data frame.shape. But we are not calling our data frame the head, right? We call it, what do we call it? Student the head. You understand? That is what we call it. So if we want to check the shape, all we can do is just to put the name of our data frame here, and we say they have student they have the shape. If we run this will tell us it's 10 column 6, telling us we have 10 rows and 6 column. We don't know if it takes this as well. Oh no, it's not taking that. So it's telling us that this data is just a small data of 10 rows and 6 columns. That is the first thing you can do, 10 rows and 6 columns. The question is, why should we check the rows and columns? Please, who want to help me here? Why did you think checking the rows and columns is important?
Yeah, and before we start any analysis, we need to know the data we are working on, to know the metadata of the data, to understand the data better.
Okay. Good. Because by knowing the rows and columns, like this one, if this is my data, I have to be very careful with this data. It means I cannot delete anything from this data, no matter what. This is just 10 rows and then 6 columns. So there should be no reason for me to delete any of the data. If the data is very voluminous like the other one we have, I can easily say, okay, these ones that are giving me problems, let me just delete them. How? Imagine if I delete these problems, like 1, 2, 3, 4, 5. I have like 5 rows that are having problems here. If I delete the 5 rows, then from the 10, I will only be left with 5 rows. You understand? So the data, the volume of the data will help you when you have your some problem like this, non-value. You don't delete such non-value because of the volume of the data you have. If the data is a very big one, you just reason like, if I just have to delete like 5 or 6, sometimes I have to delete 100 data. It's not going to affect my outcome. For example, if I have the data I have here, like, okay, this one is 768 rows and 9 columns. If I have problem with 10 rows here, even if I have problem with 50 rows here, I can delete them. I just delete all the rows that are having problem because I still have enough data. And like this other one that has like how many thousands of rows and columns. So if I am having as much as 158,000 rows, and I have a particular, and I have about 1,000 rows problems here, if that is going to give me a lot of headache, I can delete them, such that I'm going to be left with 14,000 data, which is still good for me to do whatsoever I want to do. So it's very important you check the number of rows, and in some cases you don't even need to call for the shape. You're gonna get the shape from just getting the data. The data will tell you what's the number of rows and the number of columns. But that is one of the first things you can do to understand your data. Now, the problem here that you may be thinking is like, how am I going to remember all this stuff? Fine, I know I am supposed to check the shape. How am I going to remember that it's going to be my data frame dot shape? It's easier. We have for now, you can easily work with different data sheets that you just download and be checking. Like, okay, for example, if I want to check for shape of what am I going to do, you quickly check and program with it. You become an expert as long as you continue to practice. So that should not be an headache. Don't bother on thinking on how am I going to remember all these things. You can just print them somewhere and be checking them out. The only thing you have to alter is to remember that, for example, when I copied this, I copied it with the F because I was using the F from where I copied it from some of my work. I was using the F. So if I use the F like that, then it is going to give me an error that there is no data that is the F here. So you should remember that the data you are using now is no more the F, the student, the F. You can even call it data, my data, and okay, the data I'm using now is my data. So you remember the particular data you are using and you just change it. That is all you got to do. You don't have to bother yourself a lot on how to remember all these keywords. So you don't have to bother yourself much about that. All you just have to know is what to do. So once you know what to do, and you forget some of these keywords, is a normal thing. Sometimes you may even forget that some used to have bracket like this, then you may not even put it at time. And sometimes when you are used to different kind of if you are used to different kind of language, you may have problems sometimes. So just go back to the documentation and check it. For example, if I want to give definition of class now, and I just come and say, okay, I want to do a function. I just come and say function. I want to declare a function, my function. And maybe sometimes I don't even know what to do again. I just say my function, I do like this, and I begin to, now I'm having a problem. The problem is because I'm using my function here. My function is not used in Python, it's used in JavaScript. And because recently I'm working more on JavaScript, most times I want to write code in Python, I used to mistake Python for JavaScript. It's still good, it's not a problem. All I just have to do is that, okay, if I want to define a function in Python, what will I do? I just say def. If I remember that it's supposed to be def, then you can see it has been cleaned up. So those are the problems you can encounter most times. So it's good, it's normal. You can always check the documentation for it. Okay, so that is the first step, one of the first steps you can take. Another step you can take after checking the shape is that you can check the data types. Checking the data type, you will discover that it's also easier. I want to check the data type since I'm using this. I just have to change these to the data I'm using. What are the data type? the data type for, we are going to have problem here. Please, who want to, please, quickly tell me what you think should be the data type for student name, math score, chemistry score, biology score, geography score, and English score. Please quickly tell me what you think should be the data type for them. Everybody, please, let's quickly talk because of our time. Let's talk. Unmute yourself. And someone speak. Alex.
Okay, so
just speak.
The student name will be a string.
The student name will be a
the-
string. Okay. Sometimes, because it's a string, because we are talking about data frame, instead of being a string, it's just going to be an object. So sometimes it's going to say is an object. So every string is an object. Okay, good. What about the math score?
Integer.
The math score will be an integer.
The chemistry score?
Integer.
Biology score?
Integer.
Geography score?
It will be. Oh, I forgot it.
Okay. Now,
it will be a
normally,
float.
with what we declare and what we can see, student score should be an object or string. The one we understand, string is an object. Math score should be integer. Chemistry score integer, biology score integer, geography score integer, and even English score should be an integer. But when we run it, it's not going to be. This should be an integer. This should also be an integer, but this is not going to be an integer because it's already having something like object 4i, 5o. This should be an object. And you will see now, if we have an object, there is a problem. Even this one, we have an integer, is a problem. Is a problem because math score and chemistry score and biology score are not supposed to be an integer. Please, what do you think should be the best data type for math score, but all these scores? Someone wants to speak, just speak.
Integer.
Should not be an integer. Normally, what do you think they should be? Of course, it's going to give us an integer, but it's not supposed to be an integer.
A float.
Yeah, it should be a float because it means if this is giving us an integer, there is a problem. What about someone that's called okay, even this one should be a float according to what we have now because we already have 60.0 should be our float. Because someone could have scored 75.5, which should be a float. So mostly all these should be a float, but we are going to get integer for some of them. So in a case, there should be another step that should consider that. But for now, let's just continue and run this types. Now, the student's name is an object, which is correct. Of course, they should be an object. They should be an object. Anytime you see a string, an object, you are also referring to string. Then math score is an integer. Chemistry score integer. Biology score is an integer. They are wrong. They are not supposed to be an integer. They should rather be a float. So there should be another thing we can do to change all this one to a float. That should be another step. Now, geography score is already a float, which is good, it's perfect, because geography score is a float already. So we can get a score that would be 60.8, 70.9, and that is good. Now, English score is an object, which is wrong, should not be an object. So even checking the data type, we already know that the data we have is having problem. One of the problem, okay, student's name is not having problem. The name is already an object, no problem with that. Math score, a math score up to biology score normally should not be a problem, but we are thinking it should be a problem because all the scores are supposed to be in floats, not supposed to be they are not supposed to be an integer because someone will have scored a score that is a float. So it means we are thinking about it like all these scores already have a problem in terms of a data type. Another thing, geography score is perfect. Okay, this is perfect. then English score is a problem because a score should not be an object. The score should rather be an integer or should be a float. So if it were to be an integer, well, it's good, but it's not good enough. It should rather be a float. So that is another, from the point of view of this, we already see that we are having a problem here. You can see the data I sent to us, we are yet to use it. If we start with that data, we're going to just be maybe off everything, because that is going to be a very large data for us. But for now, we are using this small data. It's easier. As we understand, we are going to apply whatsoever we have used for this small one to the larger one. It's the same thing. It's just to automate. It's the same thing. Whatever we do on the small one is the same thing we are going to do on the large one. So it's easier for us as we understand this one. So when we get to the larger one, it will be easier as well. So that's why I'm using this one temporarily. Later, we'll go and apply whatsoever we have done here to the data shared with us. That one is a very dirty data. So, but if we understand this one if you understand this one first, it's going to be easier for us to deal with a large data. I just reason that we should not start with such a dirty data first. So now we have dealt with the data type. What other thing can we do? After we have considered the data type, okay, of course, we are going to be solving the problem one after the other. We are not yet coming to solving the problem. We are only talking about what step can we take. So another step we can take after checking the data is like, sorry, we can check for our column as well. But I don't think that should be a good step for me. Sorry, that is not going to be a good step I want to go into. Okay, we could check if we have a missing number or missing value, but I'm coming. The process I'm having is not the one I actually want. Please bear with me. I'm still checking for if there is a particular document I'm looking for. Okay, are you with me? Now, another thing we can do is like we can check for whether there is a non-value or missing value. Are you with me? Hello, everyone.
Yeah, we are here.
Yeah, we could check if there is a missing value. But some question that we could ask here is that what about if we have what we have what do you call it? If we are having sorry, I'm having an issue with my this app is on my okay, yeah, I've been able to do what I wanted to do. Okay, now another question we could be asking ourselves is that if we have all these things that are wrong, how do we change them? I don't want us to go to that yet, but I don't know if you actually want us to be solving the problem as we encounter the problem. But I want us to know the various problems first before we start solving them. So now, another problem we can encounter is we can check the number of missing values in each column. Is there missing value in each column? There is a way we can do this. One of the way we can use visualization. We can visualize to check if there is a missing value. So let's just call this one step. Which step are we? Maybe we should, instead of saying step 4, maybe checking for, maybe, I don't know. Let me just say checking for missing values, right? Checking for missing values. Checking the number of missing values in each column. Let's just say checking for missing values first. Checking for values. How do we check for missing values?
How do you feel?
There are various ways of checking for missing values.
No.
You can visualize. During your visualization, you will be able to check for missing value. So let me use a visualization approach. I think that one will be very interesting to us. So checking for missing values. One of the ways to check for missing values is to use visualization approach. So we have to visualize, but before visualizing, the problem I have now is that I've not imported the library I want to use for visualization. I can import Seaborn. Import, of course, we have installed Seaborn before. Import Seaborn as SNS. This is how you import Seaborn. So because I want to deal with little visualization here, don't bother yourself with that. So now, one of the ways to check if we are having a missing value is to visualize your data using Seaborn. So if I want to visualize the data, this is the code we can use to visualize. What you just have to use is the data you are using. You know, the F, but the data I was using the other time was the data we have here is this is the data we are using here. So it's just to replace this with the data we are using to visualize. So if I put this and I run it, it's going to draw the visual representation of the data for us. I hope you are seeing this. What I did was to pick the data and check every column for if we have any hand. Is there any hand anywhere? Like, you know, normally, you know, I told you this because this is a small data. That is why we can easily see that we have any hand, and any hand here. But if it were to be a very big data, there is no way, we may not even know, we may not see it. One of the ways to quickly check if we have any hand is to check is to put it on a graph. Okay, and when we put it like this on the heat map, so anyone, normally the heat map, they are supposed to be as clean as everything. You can see we have the purple background. Everywhere is supposed to be purple. Just purple. We are not supposed to have all this yellow. Assuming it's using yellow background, everywhere is supposed to be yellow background. Assuming it's using green, it means everything is supposed to, we are not supposed to have any other thing. So this one is telling us that this place is dirty. All these things, any other pattern you see is telling us that this is a dirty data. Okay, this thing is a non-value. Anywhere you have any other color that is different from the background. So it's telling us that when we look at this very well, when we check under your geography score, you have color under the geography score. You also have color under the English score. It's telling us that when you check very well under geography score, there is NaN. When you check very well under English score, there is NaN. So, and if you go and check it truly, you will definitely find that we have NaN under geography score, and every other ones you can see they are clear. Is a very so every other column we have here is a very clean column. You can see student is clean, math is clean, chemistry is clean, biology is clean, but geography is not clean. And at the same time, English language is not clean, telling us these data contain a null value. So apart from visualization, we can also use a code. You can also print out and check. Let me copy this. Apart from visualization, you can also use this code to check the NaN value. You may not even print it. You can just run it directly instead of putting print. It's not compulsory if I just run it like this. But you know, the data we are using now, we have to put the data, student ST, I don't know, student, okay, this is the data we're using. Okay, if I run this, it should tell me the number of NaN we have, the sum of them. What is the sum? So if I run this, it's telling me that under the student, I have 0 NaN. Under math score, I have 0 NaN. Under chemistry score, I have 0 NaN. Under biology score, I have 0 NaN. Under geography score, I have 4 NaN. Then under English score, I have 3 NaN. So if you go back, since we can see this is a very small data, when you check, you can easily see that here we have 1, 2, 3. And here we have 1, 2, 3, 4 NaN. So you can get that from here, through here. You can simply get that. Another thing you can do that is very interesting here is instead of getting it that way, I'm coming, you could as well ask, because sometimes you want to know, if we have different columns and we have many columns, all you can do is that you want to know this NaN in ascending order. Okay, I only want to, because if you have different columns, like let's say like we have 20 columns now, it means I will be checking 0, 0, 0, and now be scrolling down before I see those ones that have NaN. All I want now is that I want the one with NaN to come first. So I will just say, okay, do this. You can copy this code, do this, and when you do this, arrange them ascending order, in ascending order, to tell me those ones that are having you will see the difference between the first code and the second code now. All you just have to do is to change it to the data you are using. Any other one? Okay. Since I've changed it to the data I'm using now, if I run it, it's going to still give me the same thing, but in a different way. It's telling me that geography is having 40% NaN, while English language is having 30% of NaN. So every other one, they are 0. So I wouldn't expect any other thing after the 0. So I don't have to scroll to be scrolling down. You can see the difference between the two. So this is how to check the NaN value of it. And if I don't want to put it in percentage, you can as well just remove times 100 in the code. You can just remove this 100 in the code. But it's good, you put it in the percentage, right? Or the NaN we are having, the 40% of all the NaN, they are in geography, the 30% of all the NaN, they are in English language. Every other one, no NaN, because of course it's already 100%. So this is a way to check for our NaN, the null value. After checking the null value, what other thing can we do when after checking for the null value? we can
Abdul,
yeah.
sorry, I was just wondering if you could stick the code into the chat so we can grab it, please.
Oh, okay, this one.
Yes, please.
Okay, no problem. So in most cases, you don't need to worry yourself. Just copy the code. When you copy the code, you replace with the appropriate. That is the beauty of this programming. All you just have to know is what you are supposed to do. Once you know what to do, getting the code is easier. You can even just go to your ChatGPT and say, okay, this is what I want to do. Yeah, give me the code, and then you get the code. But you have to know what you are doing, or else you sometimes when you get different things, then you will not understand why it was like that. So that's just it. So when this is the code you can use to run for or what was happening here is that this code was checking for our data and checking if there is a known value in it. And if there is a non-value in it, you now say dot sum. Add all the non-value together. For example, under geography, we have 4. Under English, we have 3. It's going to add everything together. Then when you add it together, multiply it by 100. Then divide it by the length of the students they have. Then divide the length of the students they have in 2 decimal place. They have, let me check what is happening under this line. No, that is not what happens here. So divide it by this. When you divide it by this, then you check this, this one is still a keyword, and then do it in ascending order. But what this one is telling us, round up to 2 decimal, but this is not 2 decimal place. I don't know why when I have 2 here, why it's just 0.0. So I don't know. So, but this is responding to 2. You can see 2 significant figure. Okay, maybe it's 2 significant figure. Yeah, maybe 2 significant figure, something like that. So you are in 2. That is all what it means. So it's nothing much. All that concerns you is this, and this. You are less concerned about every other thing. Just ensure you put what you have as a student data, and then whatsoever you have as your data frame, and it's going to do the magic for you. So apart from checking the whether you have we have checked whether we have a non-value, another thing we can check is we can also drop a column. How can we drop a column? The next thing we can do is drop in the column. After you have checked all this, even in my own case, this normally used to be my first step in anything I'm doing. This is the first step. All I will just do is that, why did I have all this? Now let me just drop all those things I think they are not good. For example, student name. Oh, there's nothing I can drop here. I may need a student name. I don't want to drop it. I may need a maths score. I don't want to drop it. I may need okay, let's add something to our data frame before we continue this. For the same data, let's put the matric number of the students. Let's just put the matric number students math in the data. Let the student matric number be, because they are 10 in number, let's have a matric number for them. The first person maybe 001, 005, 004, 002, 008, 010, 001, 002. Okay, I've not done 003. 3. I've not done 00. Okay, 004. I've not done 005. 006. I've not done that. Maybe that person should be the first person. 006. Then 007. I've not done that. Maybe let the person come here. 007. 008, 009. I've done that 9. No. Let the 009 come here. 009. Let's assume that this is the matric number, maybe of a particular department. For example, let's put EDC. Maybe that is the, okay, in this case now, I will have a problem because I have to make it a string. Yeah, matric number majorly is not just 00 stuff. I'm trying to create a matric number. And of course, my curation now is already wrong because they are now string. I have to put it as a string. If I want to actually run this without any error, since it's a string. So the reason why I want to put another column is because we want to use drop. But normally, when I see a data, most thing I do is like, I just look at the data and look at the column first. That's even one of the first thing I do. I just check the column. When I check the column, I see like some of this column, they are not useful. I just delete them immediately. I remove them so that the number of column I would be dealing with is going to be reduced. It's going to be reduced size. I will cite an example now. Okay, if this is my data, if I run it, I've run this. Let me add it to the column we have. We have students data. I have student data, and I want to call it matric number. Matric num. Matric number is equals to whatsoever I have here. Of course, let me put this so that I can take. Is equals to whatsoever I have here. I put this, and I run. If I call on the student, oh, what is the problem? Please quickly add students, the F math num is equals to, okay, I want to call it matric number rather. I'm using the same, okay, no, it's good. Matric number is equals to student math. So what is the problem? Please check. Length of, okay, the length is 11. Okay, it means this matric number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I call it's already more than the length of my table. 001. Which one did I run twice? 1, 2. Okay, I run 1 twice. Okay, I run 1 twice. Oh, okay, yeah. I run 1 twice. Yeah, I think. Let me rerun it. Oh, what is the problem now? Invalid decimal. Oh. Okay, this one I did not put I've removed the okay now. Okay, it's now, I think it's now working. Now I now want to call the student. Of course, we already have another stuff there. Of course, it's not going to be the way we want it. If we want it the other way around, you can see this is what we now have. Matric number and student's name. And conventionally, someone would think like the matric number is supposed to come first. Then after that, student name, of course, we can still rearrange that. All you can do, you can easily get another data frame and rearrange it for yourself. But for now, that is not the target, because I can just bring this one to this place. So now the target now is like, when I want to run anything on this data, there are 2 things I think may not be useful. The name may not be useful, matric number may not be useful, or I keep one and remove the other one from my data. I want to be working with matric number. I don't need your name. I only need your matric number. So the first thing I will do is like, I want to drop I want to drop that particular column from my table. So I want to drop the name. I'm not, I want to use a matric number and I want to drop the name. All you will do is like, of course, as a teacher, mostly, we don't want to deal with the student's name. Of course, we are all human beings. Once you see the student's name, you want to be like, oh, this is my student. Oh, this is my boy. Let me just add 1 mark to it. So now we want to remove the name. Your matric number may be difficult to get, but immediately you see the name. Okay, I don't want to have anything doing with your name. I only need your matric number. So all you do is you just say your data frame does drop. So when you say the drop, how many columns are you dropping? It depends on the number of columns you are dropping. So now you just say, and of course the data frame we are using now is students, the F data frame, drop the column. Which column are we dropping? You copy the column. If you cannot type it, I want to drop the name. I want to drop this. Mostly you just copy it. And when you copy it, at the same time, you have to be careful because when you copy it, it's going to create a space. So this is it. If I put it, if there is a space, okay, there is no space, you have to bring it back or else it's not going to run. So of course, I don't need this. Since I'm only dealing with just only one, I just remove it instead of being in a, yeah, I just remove this like this. So what happened here? Dot drop. Just drop this for me.
Column.
So just, hello. Okay. This student is now having dot drop this. This is what I want to drop. Drop student's name. So axis is equals to 1. You have to set the axis is equals to 1 because the axis is equals to 1 is telling us that drop the student name from the column. That is what axis is equals to 1 represents. It's telling us that the axis is equals to 1 is from the column. Of course, you can also drop some things from the row. Okay, I think when the axis is equals to 0, you are dropping from the row. When the axis is equals to 1, you are dropping from the column. So you have to set it as is equals to 1. It's going to drop everything on that axis. If I set axis is equals to 0 and I set the index there, it's going to remove everything from the row. But majorly we deal with removing from the column here. So we want to remove from the column. And in place is equals to true. It's just a way of telling the program that instead of immediately you replace it in all the data. The one I stored originally, go there and replace it and delete it from it. This is dangerous as well. If you don't have an extra copy of your data and you mistakenly run in place equals to true, it's going to delete it from the data and you may need it later. So in most cases, before you start running anything on your data, you can create duplicates on your system. You have a duplicate somewhere in case you have to go back to the original data. Because majorly when you run in place is going to make it the original data to change. So in place is equals to true. So when you run this now, it's going to my student data frame should remove the student's name. So if I check the data frame again, the student name, that column should have been removed. No more student name, but I now have my matric number. Assuming I want to replace I want to remove like 2 other things from it. All I could do is to do like this. For example, assuming I want to remove geography score. Now, this time around, you are going to put it just in just like an array. Okay, remove geography score for me. You are going to tell us the score to the array of what to remove, like a list. You say remove geography score for me, comma. Any other thing I want to remove because it's now many. I want to remove this one again. Control C. Remove remove geography score for me, remove chemistry score for me. If I run this now, it's going to remove the geography score and at the same time remove the chemistry score. Of course, I don't want to not do that. So the difference is that in this one, you don't necessarily have to put it in the square bracket. Okay, the difference is just that if you are removing just only one column, you don't necessarily have to put it in the square bracket. But if you are removing more than one, you have to put it in a square bracket like a list. Remove the list of all these items for me. This is what you do. But since I don't want to do this, let me just delete that. So you can see this has been removed from that. So, and this is where, for example, if I have this, the data I have here, I have this data. I have a very large data the other time we're dealing with. Let me check. I have this data, and is this data? I like, is there anything I don't want to use here? If there is any of these categories, any of this one I don't want to use, I can as well just remove them. Gender, sleeping time, all these are good. Okay. Someone want to ask question? Technocrat. Technocrats, please.
Yeah,
your hand is up. I'm just saying that.
okay, yeah, good morning, sir.
Yeah, you're welcome. Thank you.
Yeah, please, the aspect where you are explaining the assays, that's what I'm trying to catch.
Where I'm explaining what?
The assays, that's okay. If we are
the assays, okay? Okay.
Yeah,
I will go back there.
Okay, sir. Okay.
Now, you see, if you check this data frame, this is a data frame where you have the column, and the rows. These are the rows. Row 1, index 0, row 2 is on index 1, row 3, you can see, row 4. As I'm putting it, you can see it's highlighting the each rows, right? You can see.
Yes.
Now I'm putting it on David. If I put it, you can see all the rows have been highlighted. You can see if I put it here, all these are the rows. Okay. But if I'm dealing with this, I'm dealing with column. You can see the column on, these are the columns. The column on names, the columns of student. Oh, I have 2 columns already. What happened? Okay. This is not the data I'm using anyway. Let me go back to the data I'm using. This is the data I'm using now. Okay. Now, this is the column. This is a column on mass score. You can see all these 75, 76, all these belong to mass score. If I go to chemistry, all these belong to chemistry score, 76, 46, down like that. And if I come here, all these belong to, so we have a column and you also have a row. If I'm talking about it, means this is the score for this person. Okay, let me check the one that has a name. You will understand very well now. Like this is the column for David. The column for David has, the row for David rather, has a column for math, a column for chemistry, a column for biology, a column for geography, a column for English, and a column for matric number. That is for David alone. But if I'm talking about the student name column, the whole column under here is a student name. Is going to contain all the names of every student. So now in your data frame, it's like a you have a 2 dimension. Like one is a column, the horizontal one, and the vertical one. This is the horizontal one here. This is the column. But if you check, this is going to be, if you check it like this is the row. But if you check it vertically, is the column. This is the column for chemistry. This is the column for biology. This is the column for geography. This is the column for English, and like that. So, but if you check the row, this is the row that belong to David. This is the row that belong to Aisha. So now, when we were removing, talking about drop, we want to drop. We say drop student. It's asking us, student, because we could have a name that if we have number 10 now, the name could be student. So it's asking us that where should I check the student from? Is it from the row or from the column? He said, no, check the student from the row. Because if we populate this with another number 10, the number 10 could so the name could also be a student name, which would be the number 10, would just be student name. That is the name. So we are saying check. Okay, for example, if you say check Airtel, and the Airtel here is on row, and at the same time, we also have another column that is called Airtel here. The program will not know the one to delete. Is it the one from the column or the one from the row? Of course, if you change this one to 0, it will tell us that there is nothing like that. But what about if it was able to find something like that? Then it's going to delete it. If it's not able to find it, then it will just tell us that, oh, there's nothing like that. But of course, we don't want confusion. You have to set your axis. And axis is equal to 1 is always indicating the column. So if you have any other question, please speak.
No, it's clear now. Thank you. Thank you.
Okay, thanks. So now we have been able to delete. In the data I sent to us, maybe I should just quickly import that data. Let me quickly import that data somewhere so that we understand what I mean by deleting the column. You will understand. That is the first thing I do anytime I see I have a data to deal with. The first thing I just do, sometimes that may be a wrong approach anyway. I just quickly go to the column and, hey, what is all this? Just remove all this away from my data. Let me see the better column I want to deal with. Okay, let me, for example, import the data I sent to us. Let me, of course, I told you if you are using the Google Colab, you will have to come here. When you come here, you click. When you click it, in the folder, you come and say, okay, bring up a data. And the data I want to bring up, what is the name of that data? Okay, mask something, okay? So this is the name of the data. Okay, I'm loading the data, I'm bringing the data. So, okay, it's a CSV data. And all we do when you are importing CSV is just to say PD. Okay, let me call it my data now. And let me import it. Is equals to PD dot, oh, sorry. How do we import PD dot, we say PD dot read, right? Dot read CSV. Sometimes you cannot remember, just go and check the documentary. So yeah, everybody uses that. So I want to import this, and what is the name? I have to put the name. So the other thing, what I did the other thing was to be copying it. I just copy. Of course, you are going to clean the path later because the path is not needed. This is the data I want to use. Of course, you have to put it in the. So this is the data imported. So the data has been imported. So if I want to read this data, I will just come and say my data. If I copy and say, oh yeah, give me the data. What is the data? How does it look like? So it's telling me that this is the data. It's telling me that this is the data. Oh, check down. It's telling me I have 19,021 rows and 77 columns. What do I want to do with 77 columns? So you go and check. And the problem is that sometimes you may not even be able to check all the columns. You may not be able to check all the 77 columns. Some of them will have been hidden. You can see, I can see ID, I can see the name, I can see long name, I can see photo URL, I can see play URL, I can see nationality, I can see all this stuff. Oh, and you can see here, there are other ones that have been hidden in these 3 dots. If you count all these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I can only see 20, but it's telling me I have 77 columns. Where are the other columns? They are hidden inside the 3 dots. There is a way you can run your code to ensure that the other one that have been hidden here, you can see them. There is a code you can put. Let me check if I used to use that code sometimes. Let me check if I have the code. Will I just give you the code? I use that code sometimes when I'm running some stuff. Let me check. I think I used to use it sometimes. Did I use it here? But using that sometimes it's used to give problem. So in most cases, you are not advised to use it to just make the job look somehow for you. So, but you can use it to just quickly check. When you use it to quickly check, you don't use it again. You only use it for that column, and subsequent one, you don't use it again. If I'm able to check the, to get the, okay, I can't get it for now. I can't get it. I can't get it. Once I see it, I will let you know, and I will give it to you. I use that sometimes. Okay, I can't get it now. So there is a code you can use, or you can even Google it and say to get all my columns in a data frame. You are going to get the code. Now, but now that we can't get it, there is a way you can call for dot column to get all the columns, all the 77 columns. You can call for dot column. And when you call for dot columns, you can get all the 77 columns. But now that is not even the problem. The problem now is that the argument that I was on an argument that like before I start anything, mostly I remove some things I think that are not necessary. I will just think like, what did I want to use this form for? The URL, if I check like, I don't need the URL, I will remove this column. Then did I need the nationality? If the nationality is not important to the task I want to do, did I need the club? Is it important to what I want to do? If they are not important, I will just remove them from my column. So it's going to reduce my headache. It's going to reduce what I have to deal with. Because the way I'm seeing this now, I may not need it. The way I'm saying this now, I may not need it. So if I don't need them, the way I'm saying this now, I don't need the pictures. I may not need them. So if I don't need it, I will just remove them. I just go and remove those columns. So instead of, for example, if I remove like, I'm able to remove like 7 of them now. It means this column should reduce to 70 instead of 77. So my problem of dealing with 70 columns has been reduced to 70. So things like that. I think there was another one we deal with the other time. We used let me see if I'm able to get that. Okay. This is a data that we used the other time. Okay, this is the data. If you check this data, you will see that there is employee ID. In most cases, you don't need this ID. So the first thing I will just do is to remove the ID. I don't need it. I don't want to work with the ID. It's just a number, so I don't need it. So what I can do is just to remove the ID. So instead of working with 10 columns now, my columns will now be reduced to 9 columns. So that has reduced my headache. So if I have any other one that I think I don't want to work with, I will just remove them. But you don't just remove, you must be sure if you need them or not. So that is where this dropping becomes important. So you can drop most cases you have to drop some of the columns, and this is the way to drop them, which we have just demonstrated. Now, apart from dropping, what other step? We have dealt with the step of dropping the column, which we have done, and we're able to get this. So this is just by the way. Let me create empty space here so that I can continue with other steps we can do. After dropping, what other thing can we still do? If you have dropped your column, The other thing you can do, you can rename columns. You can rename columns. There are some columns that the name you gave to them or the name that came with them, you don't like it. You have to rename. For example, if you have, let's see this. If you have a name that you think like, this could have been like this could have been like this could be a better name for it. I don't like this name. Okay, let's go back to the data we are using. The next step is to rename our column. And this is a way to rename a column. Let me just put it as a comment, renaming columns. But before we rename columns, we can get columns name first. Yeah, let's get and rename column. Let's put getting and renaming columns. Let me put this code here. How can we get our column? For example, for this one we can say the have. What's the have are we using them? Student they have. There's a student they have dot column. Now there are two ways, okay? Dot columns. Dot columns, okay. What am I doing? I just want to enter and I'm doing something else. It's already bringing it for me, so I don't need to dot columns. So if I run it, let me put some space so that you can see what I'm doing properly. This is it. The student names. Of course, we can see all the columns here, like maths is going to, now, of course, we have deleted the name. So it's going to start from the math column, chemistry, biology, give us all the columns. Like in this other one that were 77, if we don't know, there is a way we can do that. So we quickly go there and do that. So if you say run this column, the column's name, so it's telling us that these are the columns name. Math score, chemistry score, biology score, geography score, English score, and maths none. This is how we run it. Now, for the 77, assuming we want to get all the 77 columns here, we just come here and say, we call on, what is the name of this data? My data. My data, please, are you with me? My data, you know, this is different from what my data is different from the one we are using another data now. Dot columns. Dot columns. So if I run it, it's going to bring all the 77 columns. These are the columns. Those that were hidden that we can't see. Because if you check these columns from after club, there are so many things that have been hidden for us. So there's no way we can see them. So after the club, when you see age, this is the club. So we have other columns like contract and all these things, they were hidden for us. So we can't see them. These were all the columns that were hidden in that particular. So heading accuracy, sort accuracy, volley, skills, dribbling, curve, all these things were hidden. Now, let's go back to the one we are using. I just quickly come to this so that you can see now. This one, we can see everything, but now we have called all the columns. These are all the columns named, but we want it better. We don't want the column name like this. So let's copy. Let's, I just really like, okay, I don't want these names. The name I want are these. These are the names I want. For this one, that call itself, okay, I have to always do this so that we don't run into an error. This is the data frame we are using. Student's name. Most times you fall into this error. Student name, the have. Now, that has been corrected. Now, the old name, this is the old name for this. Math score. I put the old name here. And the new name I want for it is this. I want it to put it as math score. I want it like this. I don't want, so that anybody that sees that will see that, this is a score. You understand? So if I run it like this now, and I go back to this, that math score will have automatically be changed to the format I want it. So this will be changed to math score. You understand? The same way if I want to write chemistry score, biology score, I can do the same thing. So this is a way to change the score. And this is how you will check every ones you don't want, and you change them individually. No, I don't want it to be like this. I want it to be standard like this and to be called math score. Or I want to put Ivan. I might decide to say I want to put math Ivan score, depending on how you want it. Oh, I want it like this. I want biology score. I don't want matric number. I want it matric number. So this is how you can replace, you can check. There are two things we did here. We get the columns, and at the same time, we rename the column. So that is another thing we can do. Now, earlier, we talked about checking the data type, but we did not change the data type. What about if we check the data type and we don't like the data type? The next thing we can do is to change the data type. Let's go back to checking the data type. But before we can change the data type, we have to first check the data type. So let it be, we want to checking the data types of a column. Okay? If you are checking the data type of a column, we already changing the data type of a column. Before we can change it, we have to check the data type. Of course, what do we use the other time? We say df student df dot the type. So this was what we got. Of course, this time around, everything has changed again. You know, matric, we have removed some things from it. So the name is no more there. We have matric. And now we said the math score should not be an integer, should be a float. So we have to change this one to a float. So simultaneously, as you are checking the data type, you are changing the data type, those you think that should be changed. Though sometimes we may have problem with this. We may have problem with this if we don't correct some things. Like for example, if we don't correct this one that is having string, if you want to change this to float, it may tell you that you cannot change an object to float because it depends. So let's check if that will not flag an error. So if we want to change it, we can say, okay, check the column. What is the name of our data type? Data we are dealing with. Let me put a space so that the data we are dealing with is they have student they have. This is the data we're dealing with. So let's change everything to student they have. So we have corrected that. Now the column we want to deal with. So we now be checking them one after the other. You can see it's a lot. Considering like you have like 77 columns and you have to be checking them one after the other. You have to do this. If you don't do that, you will. That is why 60 to 80, 85% of your time is going to be on data wrangling. Every other one are easier. But this one, you spend 60% to 80% of your time doing this. Every other one becomes easier but if you fail to do this, the other ones will give you a problem. So you can see everything, most of the thing we'll be doing now is data wrangling. We'll be checking them one after the other, depending on the quantity of even the quantity and even the quality of your data. If you have a very good data, then you spend lesser time. but you have a very dirty time, then you spend, for example, you have a project that will take you like 20 days to complete the project. Just know that the cleaning of the data will not take you anything less than 12 days. Will not take you anything less than 12 days, depending on the data. Because every other, it means every other thing you just have to do is just going to be under 6 days, you should be able to complete the project. If the project is meant for 20 days, the project is meant for 20 days, it means that the project should not take you more than 6 days on average. But because of the data cleaning that we default like 10 to 12 days to do, more than half of the time, you default it on, if not even up to 16 days to cleaning the data. Every other one become easier and just to copy a code and paste, that's all. But this one, you don't just copy and paste, you understand what you are doing. You know what you are doing. You know why you are doing it. Now, I think one of the column I have to change is this. I have to change this column. This column that is math score, you put it here. This is the math score, okay? That math score is still the same math score. I still want it as student math score, but I want to change it to floats. If I run it now, it will be changed to floats. If I call on this again, you will see that the student data type will have been changed to floats. Look at this. You look at it. The math initially was the score was an integer, and now the math is now floats. The same way you change it to integer, you change the math score, you can change the chemistry score, biology score, geography score. Now the questions will be, how should I change all these? What about if I want to change these three to the same data type? Should I be doing them one after the other? Or should I put them as a list? Or, of course, there are different ways you can automate that. You can do that. You can just copy everything as a list and then change everything to the same data type. You can do that. You can do them individually. You can write a for loop for them. In so many ways you can do them. But for now, just cool your head and know that, okay, even if you have to be doing them one after the other, no problem. The goal is that you want everything to be, if I copy it up here again, and I want to change another one, another one I want to change is that I don't want, okay, matric number is an object because I already have matric number like something, something on it. So, but this one that is English score, that is an object, I don't think the English score, I will be able to change it because it has a string. I don't think the string will accept you changing it to float. But let's see. If it's not accepting, you just have to go and clean that data first before you can even do some other things. There are some things you have to do in most cases before you can do some other things, like cleaning it up. If I want to change this, I don't know if it's going to accept. You can see, it's not going to accept that from me. Say, no, you cannot change English score because English score is an object. There is no way you can change an object to float. It means this particular data is having a big problem, a bigger problem other than just changing the score. If I go and check the data, you will see that under the English score, I have this string here. There is no way I will say 4 points. In fact, I even have 5.0. There is no way you say 5.0.0. There is no way you will say 4 what is this one now? Borrow me grammar. What is this? What is this? It's not okay. Exclamation, okay? This exclamation, I will have to first go and look for a way of removing this exclamation or changing this 50 to 50 and change this 4i to 4, or even just change this to 0, or change this one to 41, or change this to 40, or change this to anything I think I want to change it to before I can now convert it to float. That is why it won't allow this to be changed to float. It has a problem. You must remove all these special characters from it. that is still a very big thing to do. So we can't do that for now. So, but now you know how you can change data, you can check the data type and change those ones that you can change. Don't want those that are easy to change. So on the ones that are not easy to change, we're also going to talk on how to remove special character. But let's continue with the step we are taking. Another step is we have what is called missing values. How can we undo the missing values? This is a lot. This is a lot. Changing, maybe dealing with missing values. Earlier, here, we have been able to detect that we have missing values. We have various ways of detecting missing values. For example, we say we can use this. When you use this heat map, under the heat map, you are able to see that, oh, this one that is having a missing value, you can see, is already showing that under the geography and under the English, we have a missing value because of, normally, all this one that is just purple, depending on whatsoever the background is. If the background is set to green, everything should be green. If the background is set to white, everything should be white. But once you have another color that is different from the background, it's telling you on where you have this color, you have a missing values, and this is it under geography and under English language. And you can also confirm that using, if you don't really want to use that method, you can use this. You can confirm that. You can see it's telling you have 4 missing values here. You have 3 missing values here, and you can also check based on what do you call it? The percentage of the missing values. It's telling you 40% of the missing values, they are on geography, and 30% of the missing values, they are on English language. Now, after knowing that we have a missing value, what can we do to this? We already know there is a missing value, there is a problem. What can we do to these missing values? So, what we do, let's just say handling missing values. How do we handle the missing values? Oh, there are ways of handling missing values. Dropping rows with missing values. So this one is telling us that we can drop, there are different ways. We can drop the rows with the missing values. You can see now that we say in place is equals to true. You know, we are not saying, we are not setting the index to be equals to, unlike, the other one. We set this to be equals to 1. Yeah, we set axis is equals to 1. It means that the default is when you don't set the axis to be equals to 1, the axis is going to be equals to 0. That is going to be the default and 1. So whether you put it, once you don't put it, it's going to consider the row. So that is what actually happens here. Because we are not setting it, since we didn't set it, is the default. So automatically, we can, okay, let me do it this way. Handling missing missing data. Okay, let it be like this. If we want to handle missing data, there are ways we can handle it. Dropping the rows with the missing data. We can drop the entire row. Any row that have this missing data, so yeah, drop it for us. Dropping rows with missing values, like we just say drop everything on the rows, like it's going to check. For example, let's bring our data up again so that we can have access to this data. Before, let me just put it here. The data we are using is ST student data. Okay, this is the student data we are using. We are saying in this student data, check any rows that has, you can see, if you check this, if you drop it, it means it's going to drop everything. It's going to drop all the number 6. At the same time, in fact, it's going to draw where? It's going to draw number 2. Number 2 is having, it's going to drop everything here. It's going to remove everything. It's also going to remove everything number 5. And it's also going to remove everything number 6. It's also going to remove everything number 7. And I don't want to do that now. What can I do? What we can do is that we can create another data from this data. maybe we should just let's create another data before we start dropping them. Let me create student data 2, data 1. Let me just copy a data from student data 1 is equals to student data. Okay, if I run this, so if I now I'm not going to be running student data again. Let's run student data 1 so that we can drop anything we want to drop on. So you can see student data 1 is a copy of student data So that at a point, if I drop everything and I still need it back, I can always go back to my student data. So now on my student data, I want to drop what we can do on that student data 1, or is that called student data 1 or student data? Okay, student DF1. So if I drop everything on that, what we can do, dropping rows with missing values. We can drop the rows. So what was the argument? We are saying dropping rows with missing values. So we can drop the entire rows. When we are dealing, what we are doing now is that we are handling missing data. And when you want to handle missing data, you can drop all the rows that has a missing data. So if we come here, we can say, okay, drop everything on student data for me. Student data 1, I don't want to tamper with student data 1. You can see there are 2 different versions now. If I drop it, it's going to drop everything so that have NA. So if I run student data 1 now, it's no more going to be the former student data 1 we have. If I run it, everything will have been dropped. You can see there is no anything like that. Any rows that contain that will have been, it has dropped 1, it has dropped 2, it has dropped 5, 6, 7. Everything has been dropped. Now, the disadvantage in this one is easier to just drop everything. Is that if your data is not more, it's going to reduce the data you have for use, and that becomes a problem. So you can see now it's now cleaner. It's better now. We no more have we no more have any other what do you call it NA. But apart from that, another thing we can do is that we can input instead of just dropping. It's not always good to drop. The other thing we can do is that, okay, instead of dropping, why not just input? By input something. Let's input something there. So let's say input. This is not good enough. We still need some of these students. We still need some of these things. The only thing that they don't have is like if you check this data very well, you can see the data already have math score, have chemistry score, have biology score, but not having biology score. And let me score this person 0 here. I can score you 0 here. So which would be good if I decided to score you 0, or I say, okay, come back for another this thing, or let me just give everyone that are not scored, that didn't come for the exam or for the test whatsoever, let me give everybody 25. So it means all of them will have 25. There are cases where all you have to do is to just input 0 for everyone. Anywhere you have NA, input 0. You can see it's still going to give every other, it's still going to keep all our data. Instead of removing the data or reducing the data to what we have, we can begin to input some other things here. Where anywhere I see any hand, put 0. Let's just put 0 for all of them. Or in some cases, let's fill with what we have in at the front. If I see 50 here, anything that comes before it, I will put it. So where I see any hand, I will put 60. I go to the next one. Here, where you see any hand, you just say, okay, fill it with 34. So here you may have problem. Like if you sit with someone, maybe if you are next to someone that has 60 score, then it means your own score too is going to be 60. Then you that you are now next to someone that score 34, then it means you are also going to score 34. You are next to this, then you're going to score 34. You are next to this, then you are also going to score 34. That is fill forward. There is another one that is fill backward. Okay, no, Pick the one before it, okay? Because I now have 85 below me now, with myself, I'm still going to score 85. Here, this person has 93. It means those people above it that has no score will also score 93. So that is how to fill. You can fill with just imputation. Let me just, okay, random imputation. I want to give everybody 0. You can put with random imputation, or you can use feed forward, feed backward. You can use it to fill it. Another thing you can do is you look at it and say, okay, let me just check for the mean value. What is the mean score? Let me input mean score for everyone. Or let me input the minimum score. What is the minimum score in this? It means the minimum score is 34. Anybody here that didn't come cannot score beyond 34. So everybody should score 34. Let me look for the mean score. The mean score depending on the aim of what we are doing. If this is going to be, you are going to be biased here. If somebody that came for an exam score 60, and somebody that did not come at all, you just say because someone in front of before the score 60, okay, I want to input 60 for you. It's going to be biased. What about someone that came and scored 34? And someone that did not even come at all, you are inputting 60 because 60 came before it. There are conditions where it is necessary. But in this case of what we are dealing with score, this is going to be biased. Or someone that did not come at all now, somebody scored 60, and someone that did not come at all is now scoring 85. This is bias. So you have to have the knowledge of what you are doing before you just continue to input a score. See someone that came for a course scoring 34. The other people that did not score now come now because you are using feed backward, that person will now score 93. It's not making sense. So there are cases where they will make sense. There are cases where they don't make sense. So that is why the knowledge of what you are doing is very important. I told you already that data wrangling is the one that takes the big aspect of our time. We cannot finish this data wrangling. We cannot finish it today. Even in our next class, we can just rush over it. This is what you do over and over again. Because if you fail to do this aspect very well, you are going to get a data that will give you wrong information. Imagine you are inputting 85 for someone that didn't come at all. Now, you imagine the kind of data you are giving out. So we have to spend a lot of time on this, and by what we have, the time has gone. I don't know what we should do. So please, let's quickly do some remark before whether to still spend some time. But definitely we cannot, because this is the major part of what you call it, of data science. Is the major part. In fact, 90% of everything we do should fall under here. So please let's comment before we continue or we stop for today. Back to you, please, if you're here.
Yes, please, I'm here. Thank you very much, Abdul. It's been an amazing session so far. Hi guys, any question, please? Should we continue for another 30 minutes or we continue next class? I think the floor is open for us.
I'll be happy to continue 30 minutes if we can finish the input bit.
Okay.
Yeah, I'll also be happy to continue.
All right, great. Abdul, that's fine. We can continue for the next 30 minutes. The session is being recorded, so if you've got to go, that's fine. We'll share the recording early next week, as always, and you can always check on the website on the Content Hub page, and also the WhatsApp group is live. If you're not in the WhatsApp group, I'll share the link to the group in the charts. Then feel free to join the WhatsApp group. Every information is being shared. So Yeah, thank you. For those who want to leave, it's fine. We'll share the recording Monday, Tuesday maximum. Thank you.
Okay. Good. Let's see, continue. It's a lot. It's a lot. It's a lot. But we just have to get it right. Because that is the major thing we do. And as a data science or analyst, we claim. Inability to claim becomes a problem for whatever model we are building, for whatever outcome we got. We have to claim properly. Now, in some cases, it's especially when the data is much. For example, this other one that has what is the data size here? Let's take this one. Look at the data size. If I check, let's quickly check NA in this data. If you check NA in that data, checking the NA value, those that have NA, how do we check our NA? Let's just copy and paste. Just copy the code. I don't want to. Yeah, let's just copy this code and run on the big data that we have. So you see bigger data, this bigger data that we use my data for. Let's check the NA in this one. You see, but this case, we're gonna change it to my data. I think that was the name. Yeah, that was the name I used. If I run, you are gonna see. You see, oh, this is still okay. You see, it's telling us pass as 5. This but each has 2,595. But I don't want it in this format. Let's check the other format. The other format that summarized for us in percentage. This one will be better for us, since it's going to summarize it for us in percentage, and we see those one fall before. Okay, let's check the data here. You see, this one may not be easier for us. We're gonna change this to my data. Again, we're gonna change this one to my data. Oh, my data. So if I run this, look at the percentage. 90% of all the NA is under loan data end. Okay, another one is under its. Yeah, so it means you can see that we have some things that are hidden here. You can see it's hidden. And so because it's hidden, we can't actually see what we have here, except we use 4 to run this. Except we use 4 for maybe data and this. If we use 4, we should be able to get this. Just say print data. If I run it, I believe this should run. Okay, you can see now, when I run it, it runs everything. You see, we have some that contain 3 NaN, some that contain 1, 1, 5, 8, 8 like that. You see, some that contains okay, these are all the data we have, the NaN we have. One contain 2, 5, 9, 5, another one contain this. So these are just what we can do to get the data. But let me go back. You can use 4. Now you see the importance of 4. You can use 4. So now, if we have this data, if we go and drop it, we have 19,021. If you go and drop the data here, let's just drop, and you will see what is going to reduce to.
933.
What do you say?
933.
Okay, you have dropped it already.
Yes.
Yeah, good. So let's just drop it and so that others can see that, you will see the disadvantage of dropping everything. Sometimes it may still be sufficient. Sometimes it may not be sufficient again. That is good. We say we drop the data, my data dots. When I run. So I've run it. Then let me bring my data back and run again. So it means this my data is now 993 rows from, you see the problem, from
19,000.
19,000. You can see. So it's going to be very wrong for anyone to come and drop this kind of data. From 19,000 data, because you don't want to do any computation, you don't want to do anything, you drop and it drops. So in fact, this is very negligible. 900 to 19,000 is negligible. So you will see that because you just want to drop, because we are lazy, we don't want to compute anything, we just want to drop it, you are going to reduce the data you have. But if it is the one that can reduce to maybe 17,000 from 19,000, it's still good. 18,000 from 19,000, even 15,000, I will still take it. But if you drop it to something like 900, so it is not a good one. It's not a good one. So you see the problem with dropping a data. Dropping it, dropping NA is not going to be a good idea in most cases. So if that is not a good idea, what other thing can we do? We can input. We say dropping with missing values. Okay. This time around, we are not dropping with missing value. Oh, what did I do? We are not dropping with missing value. What we want to do, we want to input. Dropping, no. Imputation. What's best grammar? Please borrow me a grammar we can use. Inputting, let's just borrow ourselves a grammar we can use. Let's just say imputation.
Or filling.
Okay, I don't want to use filling.
No.
Because filling itself is a method under the input.
Okay.
Let's just say imputation of values.
What about replacement of missing values?
Of values. What did you call it?
Data.
Replacement of missing values.
Yeah, that is great, man. Let me change it. Replacement. Replacements of, yeah, this is great. You know, sometimes grammar will just run for you. Don't mind all this spelling sometimes, no? Replacement, okay? That is not our goal. We are not English language here, so that's not our goal. So our goal is to guess what we are doing. Now, when we want to replace, how do we replace? There are various ways to replace. One of the replacements we're going to be doing is we're going to be replacing, well, we can replace with let's just say with median. Sometimes it's good we can use median to replace, right? With median. Sometimes we can replace with
Mean.
With main, yeah. In fact, let me just say, instead of saying with, let me just say main. We can replace with main. In fact, we can replace with mode, okay, depending, okay. For example, I have data where I'm dealing with a number of students, and everybody that be saying male, female, male, and someone did not put. And I already have 100 students. Out of this 100, I already have maybe 70 of them says female, and 29 says male. It remain one, or even remain two that didn't say anything. Maybe 28 says male. So I have to end here. And I don't want to remove the whole column. I don't want to remove. I can just say, okay, let the two be female because the mode is already female. So the probability that those are going to be female is almost 1. Do you understand? So you can use mode. You can use median. You can use mean, depending. There are cases where you can use median. There are cases where you can use mean, and there are cases where you can use mode. It means you have to understand your statistics very well. You don't come to a categorical data and be saying that you want to use a median or a mean. A categorical data may not necessarily have a mean. Okay, what did I mean by categorical data? Your column can be divided into categorical data and a numerical data. When we check this, let's go to this data. We have students, we have math, we have all these ones, they are all numerical data. But when you check your students and your matric number, they are categorical data, especially they are objects. Those that are objects, you don't come and tell me that if someone did not put a name at number 10, for example, we have every other thing, but the name is not there. You now say, let's input the mode. It's not possible because you cannot be, okay, let's input the mean. There is no way you can calculate a mean for the name. Okay, let's say there is a response where everybody is saying yes, no, yes, no, yes, no. And there is one that did not put any response here. Maybe in attendance, I will just say yes, no, in an attendance. We have another column that says attendance. And we have like 2-3 people that didn't, we don't have any record for them. So whether yes or no, there is no way you can put the mode, and there is no way you can put the main, because there is no way you can calculate the main for a categorical data. The most important thing, the best method you can use here is just to use mode, because you just say, okay, since all of them said yes, okay, majority of them said yes, let me use yes for those people that didn't put, that we don't have record for. So you have to check what you are feeling. Is it a categorical data or is it a numerical data? If it is categorical data, if it is numerical, it is easier to calculate the median. It's also easier to calculate the mean. But if it is numerical, rather, it's easier to calculate the median and the mean. But if it is categorical, you can't calculate the mean. You can only take the mode. Then you can replace it with the mode. So you can use this as a replacement. So apart from replacement, the other thing we can do is to fill. Yes, filling. Yes, I think this is good now. Replacement, we can also do filling, with what someone said earlier. You know, I told you filling is a method on its own. When you do this replacement, you want to replace with mean, or you say you fill with mean now. You fill with median, you also fill with mode, which is good. Or you also fill with random, yeah. You can just use a random, for example. I decided to fill 0 for everyone. It's a score and you didn't come. The best thing for me to do is to give you 0. So if you didn't come, I will just come. I won't even bother myself. I will just input a random number. Random number. Maybe you came, you have an attendance with me, and maybe if the attendance is 10, I can decide to give you 10 for not coming for the exam. So you already have 10. You have the score. That is a random number. It's neither the mean, nor the median, nor the mode. It's a random number, or something like 0. 0 is the common one that you can always give. You can always give 0 for everything that doesn't have, that is a missing value. Just give 0 and leave the place. It's easier. But filling can be, you fill with back filling. Forward, we have forward. Oh, how do you write forward again? Forward, and you also have backward. Remind me, if I write anything that is not correct, just take it like that. Take it, if the spelling is not correct, take it like that for me. You can fill backward, you can fill forward, and we also have another one that is interpolation. you can use interpolation. I think interpolation, is majorly meant for time series. I've never used interpolation before because I've not worked on time series. I think that is my next one. I've worked on natural language processing, but I've not worked on time series. Yeah, I've not worked on time series. So I think time series, basically, interpolation is used for time series. Yeah. So maybe I should just separate that because it's a different one entirely. Interpolation for measuring value. Yeah, is a different one entirely. You don't just use it anyhow. It's used for time series. So if I have a data that is a time series data, I will be talking about you can't use any of this method. The best thing you can use is the interpolation method. So that is the best thing you can do. So it's a different one. Now, how do we use replacement? We have dropped. How do we use media? How do we use main? And how do we use mode? So let's quickly look for a way of using main, media, and mode. I have a code for it. Let me just copy my code. You can see it's always easier. You don't, especially when you have done a project before. The major thing you just need to do is just to do a project once. Once you have done a project once, everything becomes easier for you. I hope you are still seeing my Google Colab. Are you with me?
Yes.
Hello, everyone.
Yep.
Yeah. So let's quickly say filling with replacement like this. So if I want to replace, before we do that, let's quickly duplicate another, we can use the same, the here. Okay, students, the here. Let's have student duplicate this time around from the here. Let me just say duplicate. I hope you understand what I'm doing here. I want to get another data. I don't want to tamper with the student data. We already have, there are two data we are using from this data. We have this data already. We also have the one that look like this already, which we have dealt with. Then I want to create another one. Maybe I should just call it 2. DF2 now. Okay, think so. It means we are also going to have another data like this, but this time around, those are the 3 data. I clone these 2. I'm cloning these 2 or copy them from here. Yeah. So let me run it. Because if I am to refer to this, it has dropped them already. So there is no way I can use the one that has been dropped. So now I want to be working on this. You can see it's it means it actually copies the memory location. You can see the problem because when you use in place, it becomes a problem. You understand? You can see we are now running on the problem. Oh, the best thing I can do now is to go back to where I declared them. Yes. Let me go back to where I declare and rerun from the beginning. Or else, I won't be able to get that data back because I already used in place. I hope you understand what I mean by the problem of the in place now. Okay, I have this. Now, let me now rerun this dictionary. Okay, now since I rerun the dictionary, and I can now give it to this data, that I'm just trying to slice out. Yes. When you use in place, it becomes a problem for you. If you don't have a copy, then it means it's referring to the same. I didn't use copy. Yeah. I didn't use copy. Because I didn't use copy, they have the same memory location. So there is a way I should have used copy to copy it so that they won't have the same memory location. But since I didn't use copy, they have the same memory location. Oh, see the one I'm getting? No, it's not this one I want. I want a place where I have added another, okay. I've added all this to it now, okay. Let me run it here. Where I added geography to it. Let me see another place where I added some other things to it. I added them back to it here. I hope you are getting what I'm doing. I'm trying to clone those things back. Okay, I did this. Then I run another. Okay, this is now the student. Let me now go back to where I cloned the new one. I actually am supposed to have copied it instead of just using it direct. Okay, this is it now. So I think I should now have the same data. Yes. This is the data I want. This is the data I want. So you see, this data I have here now, you want to replace by the have. This data is now next time, because of our time, I will tell us how to copy instead of because this one we did is equals to they are referring to the same memory location. So that is why anything, and when you use in place, then it becomes a problem. Immediately you use it in place. So it's going to change it from the original memory location. So this data, I don't want to change everything. I only want a specific column. Let's deal with a column here. Let's take this column alone, okay? I don't want to take everything. Let's say check anywhere you have NA in this column. Of course, you know how to slice the columns out. This is how to get the column, a specific column. We don't want to deal with the whole data frame. We only want to deal with a specific column from it. I want to use fill NA with median for that one. And for the other one, I will go and copy the column and you fill maybe with another thing. Okay. If I fill it with median, what am I filling? I'm filling this. You see, this is what I'm using. I'm not saying the whole. Please note the difference between when I use. Please let me clear this place so that you understand what I'm. This is what I should have done straight. This is what I should have just done. Okay, I'll run it. But if I run this, I'm saying check all the NA in the data frame of these students and replace it with the median. So if we check everything and replace it with the median, everything, all the data frame, if we check all the NA, whether the one under the geography, under the English, if there's anyone under biology, if there's anyone under chemistry, it will check everything. If I run this last code, it's checking for everything. But if I run this one, it's not everything. It's saying, okay, from all the data frame, only go to the one that has geography score, that is the column with geography score alone. That is the one I want to deal with, and not everything. Please note when you are dealing with everything and when you are picking. In fact, the best thing is to even pick them one after the other. They may be unique. What you need to do to a geography column may be different from what you need to do to English column. It may be different from what you need to do to biology column. It may be different from what you need to do to chemistry column. So take them one after the other, not everything. In most cases, it's not good to deal with everything based on every column. Every column, each column may be unique. what I have to input on every column may be unique. So sometimes, okay, here I want to use, for this one, I only want to use the median. For this column, I only want to use the mean. For this column, I only want to fill forward. For this column, I want to fill backward. For this column, I want to input. For this column, so you can use it that way. It's better than to pick everything. So I only want to deal with the column on geography. That is why I am using this first column and first code. So let me delete this code. Okay, let me leave it so that later, if you want to practice, you will remember what it means. So I only want to deal with this. If I run it, I want to fill with media. Should I fill with media on geography? If I'm dealing with geography, it's going to have 60 with median. Okay, what is going to be the media of this? I don't know, but mathematically, when you press your calculator, you should be able to calculate the median. Whatever you get as the median will be used to replace the NA. You will discover that there is an NA on index 2, and there is also an NA on index 5. If we run this, it's going to replace all those ones. Let's run and see. So it has been run. So let me check the data back. After it has been run and run it again, you will see that everything under geography has been filled. So everything under geography, you can see on index 1, the Aisha has been changed to 66.5. All these ones that have been replaced, all the 66.5, they are the what? They are the median. Is it the median we use? The keyword you use here determines the method that will be called on it. If I use median, it means the median has been used. If I now turn it to mean, it means the mean is going to be used. If I turn it to mode, it means the mode is going to be used. So let's use it on, please someone to tell us what you think we should use on, we have used median on, we want to consider, of course, if you check this, if you check the data now, it's only one that is only an English score that contains NA. And we cannot use median here because this one is an object. It won't calculate median for us. It's an object. So the only thing we can use now is mode. It's going to look at it and say which one is the mode, and then we use it. And I don't know if there is any mode here. If there is no, okay, let's see. Let's see if we can use a mode. Anyone? This time around, we want to deal with English score. In this case, the problem we have here is that before we can even do anything on this English score, we have to deal with all these special character. There is a way we have to do with, okay, check all the special character, remove them for us. Then we have to deal with special character before we can even deal with the NA. But let's see if we can get anything with the NA. I doubt it anyway, because it's going to be telling us that, no, we cannot calculate for mean. No, there's no way you can calculate mean for a special character. So the only thing we can calculate for it may be a mode, or we use an imputation. Yeah, we can just input. I think that is the best thing. We, instead of using mean, median, and mode, we can just use imputation straight. It means that is not going to be a good one. We can just use random number. We can just input random number for it. Like say, okay, and let's input 0 for it. There is a way to input 0, and the only thing we're gonna do if we want to input 0 is to just use this code. Of course, the mean has no problem. It's the same thing. It's just to change the name to mean, median, and mode. It's the same thing. But under for this one, for us not to get run into any problem, the best thing I think we should use for this one is to use imputation. Let's just input 0. Or what do you think we should input? Check it very well and tell me what you think we should use. What you just think on, instead of using 0, let's just input 20 for every NA. Let's just input that for every NA. So let me remove this one. Here, what we are doing here, the only thing we are doing here is that we are inputting 0. So, or if you don't want 0, fill NA with 0. Of course, we use in place again. Fill NA with 20. Fill NA with your desired number, anything we want to fill it with. So what did you think for this score? Maybe we may just, since they didn't come, let me just give them 0 if they didn't come. So if I do it like this now and I run it, it's going to give all of them 0 since they didn't come. So if I run back the whole entire this thing and I run it, it's going to, you can see 0 has been inputted for everything that has NA under English score, we inputted 0. Under geography score, we inputted a main. If we have another one, assuming we have NA on any other one, we can choose another one again and input mode. We can choose another one again, okay? Now you can use mean, media, and mode. The only thing you only change in your code is this. Where you have media, median, you change it to mode. Where you have mode, if you want to use a mode, you use mode. If you want to use median, you use median. If you want to use mean, you use mean. So it's going to calculate the mean, media, and mode for you automatically. That is how to do that. Oh, our time is up. Okay. I'm happy to be here once again. And I hope we understand to where we stop now. And I believe you will practice when you get home, and then prepare for our next class. And we are, by God's grace, now next class we'll be able to do more and continue from where we stop. So thank you. If you have any question before we stop the today's class, please, let's hear from you. So I'm with you. You can, Blaze.
Yes, I'm here. Any question, guys? If no questions, then yeah, we look forward to seeing you all in our next class. Yeah, communications will be sent out with regards to that. Yeah, thank you everyone for today. Have a fantastic weekend all.
Yeah, thank you very much.
Thank you.
I appreciate it.
Thank you.
Yeah. Bye.
Thank you. Thank you.